yeah, I was at many AstriCons in the past and other events like FOSDEM, KubeCon, Kamailio World, and I'm always trying to pick up another topic. So I was thinking that in the past months we did quite some enhancements also to some parts of our storage backends, and having pretty many options there, I thought it's a good topic to at least go through them, have a discussion, and eventually sort out some of your doubts about which one it's better to use, when and why. I'm not using all of them, so some of them I might not have, but maybe some other guys in the Kamailio community here can help you. So I'm Daniel Konstantin Mierle, for those who haven't had the chance to meet before. I ended up to be the leader of the project. The project started in a research institute in Berlin, Germany, initially named like SIP Express Router, then it was OpenSCR, and then due to trademark issues, we ended up with the Kamailio, which Fred has the best way of presenting how to pronounce it in a more fancy way. In short, it's actually a Hawaiian word, the verb for to talk, to converse, and actually we are proud to have a street named Kamailio in Honolulu. They did it before our project, but anyhow. Being the leader these days, I'm always plugging at the beginning of my talks like what we did new in the last, 1 year or so. So I'm giving updates from the last AstriCon from here, more or less, around that time, and then I'm going to the main topic. I think I'm the last presenter today, and it was raining outside, so probably we can stay up to 7 and discuss about what we did new, and then half an hour about the storage engines. So yeah, the past 1 year and a half, we did quite a lot of new features, a lot of work of this making the configuration file, building the configuration file a bit easier for, let's say, non-developers or the developers that are familiar with other scripting languages, because we started back in 2001 with our own self-brewed scripting language, and learning another language could be like a first barrier for newcomers. So we have now many options on building this routing logic in the Kamailio configuration file with Lua, Python, JavaScript, even Ruby with the next major release, which is going to happen in like 4 to 6 weeks time frame. Message buses like NSQ, RabbitMQ, topology stripping and topology hiding, which was also approached by Fred before. We added like replication of the information relying on Redis, and actually Redis was something that our development community and the companies using Kamailio has kind of adopted as some like the preferred way of using this NoSQL directly or emulating our database API. So will be actually part of the presentation that has to follow and is related to the main topic here. So what's this scripting language? Is a bit of more background and where it can help you. So I name it actually the Kemi framework, standing for Kamailio Embedded Interpreter Framework. So again, back in 2001, 2002, when the project started, there was no suitable scripting language out there for real-time communication. So be very fast and also be suitable for recurrent execution. Like, Perl, you execute it once and that's it. There are many libraries, very useful, but they don't release memory. And if you use it many times, the same function, you see it sitting like a memory leak, so it's not a good one. So we made one which actually helped because we could tailor and optimize for what we needed. And back then, practically the needs of SIP routing were rather limited, you know, some regular expression here and there, prefix routing and so on. But later, with adoption of the APIs and other backends and integration with third-party services, our language became a bit more limited in that aspect. So we had to extend it by ourselves. And then we said, okay, learning curve is a bit higher because we don't focus on having documentation for the scripting language itself. And then also every now and then there is a new NoSQL database or a new whatever framework out there that people want to integrate with, and that would mean we have to write C code to make it available in the config file. So we decided to allow more than just our native scripting language for this configuration file, and that's practically the story behind it. To better understand if you are new to Kamailio, so practically there are two parts that we are referring, like passive one, which is used only once at startup, like listen socket and, you know, how many processes to create and, you know, all these parameters that are useful when you start, how much memory and so on. And the active part, which are what we call like routing blocks, where you decide the routing. So, as Fred mentioned before, Kamailio, it's a SIP router at the edge. You know that a call is starting with an invite, goes to some re-invites if you put the call on hold and so on, and ends up with a buy. In Kamailio, you get these packets. It's not like I got the call, what do we do with it? And then you get the invite. You have to route that invite. You get the buy and decide what to do with it. Fortunately, the SIP protocol has the elements in the header, so you don't really do a lot, but still you have to kind of baby care all these packets. So that was the active part, which was the scripting language, because the global parameters, the passive part is more like key equal value, like listen on this IP, how many children ate, and so on. And that was actually building the application logic for SIP routing, and it's where actually you can use now a different language. And for comparison, I put here a really small part of our default config file, the route SIP out, which is testing if the target domain is a local domain for Kamailio or should be sent out to another provider or another SIP server. So this on the right side for you, bottom. And in terms of the scripting languages that we added, Lua is quite popular in the RTC world, including web, like Nginx. It's using Lua for allowing you to customize the routing of the HTTP packets. Then JavaScript, popular for the developers. In the web world, Python probably is the most used programming language out there. So finding developer, it's easier on this, that know this programming languages, it's easier than finding one that knows the Kamailio scripting language. SQL, it's something small, which I did more for didactic purposes. It's based on Lua as architecture with some small changes, not really popular. It was very simple to implement based on the comparison with the Lua, and the Ruby for people that don't like Python for whatsoever reason. Or I'm not using the scripting languages, but making the interpreter was not that complex. We still have other scripting languages that you can use, like Perl. It's just they don't expose the Chem interface yet. Also Mono, the interpreter for the .NET group of languages and so on. And there is a Java connector, more or less. I haven't really used it. And again, the native scripting language is what we refer to, what we have developed from scratch. So now just a few slides to see the comparison. If you back, again, this is native scripting language, route SIP out, checking if the URI is myself, going back if yes, and routing to list code routing load balance. Otherwise, sending out, adding a header like phint outbound. And here is the equivalent in the Lua. So practically now you have to define a Lua function with the syntax from the Lua language and calling some API that we export via KSR module to the Lua language. So practically the interpreter is now Kamailio, and besides the Lua modules and libraries you load in your Lua script, you have this KSR module which is automatically exported, and based on the modules, like here KSR HDR, append header field, so it will append the header using this HDR submodule. So rather simple and one-to-one relation. And then the equivalent for the Python, more or less the same, is just a different way of defining a function specific to the Python and then using the same KSR module. Of course, the beauty and flexibility comes plugging extra logic here using external libraries you find in Python or Lua or other scripting language that you are using. Here, if you want to read more like documentation and what we export, again, is not the topic here to really focus more than that. I wanted to just give you a bit of comparison and direction to it. Other highlights, with Kamailio, we ended up over the years to be more than just a SIP router, so you can run it as a diameter server. We have IMS voice over LTE extension, and you can use Kamailio as diameter server if you want. So I put it here like non-SIP processing. So there are a couple of other protocols that we can handle with it. You can also route your own brewed protocol more or less. And the example here is like routing binary blobs that you encrypt, or here you compress, decompress using a Perl script, and then you can do the routing with Kamailio. You may need it or not. It's up to you, but again, we have this feature. Different people use it, and we had the possibility to do it. Quite useful and popular out there would be the Anycast. We had the framework for a long time. It was just not exposed there. It's about switching between source IP, local IP as you need. In your network, like you have the request on this proxy, you send it out, but the reply comes on another proxy. However, you want to match it with the transaction from the other proxy, so you can pass it. It's still SIP. You pass it to the other proxy and say, well, actually consider it that you receive it directly from the origin, not from the other proxy, and you receive it on this interface, not on the private link if you use private link for communication. So it's just changing some properties associated with the SIP traffic, and you get the full Anycast there. Again, everything is SIP, so it's not much that you have to troubleshoot with a custom protocol or something that we invested. And again, more like some summaries that we did here past this years. A very good outcome out of our community is this RTP engine. That it was a question about the TLS and SRTP. So practically Kamailio can switch between TLS and UDP TCP for signaling, but for DTLS you need RTP engine. So getting DTLS SRTP and send from WebRTC and sending to a classic SIP phone, it's Kamailio and RTP engine. It has transcoding lately, so it's a good contribution from SIPwise, which is one of the companies behind Kamailio. I think we have one of the most complete open source implementation for this IMS voice over LTE. So you can try playing with it. Topology stripping, which makes Kamailio to look a bit more like a back-to-back user agent. But actually in the config file, you still get the entire SIP message with all the headers. So you don't need to change the logic from like behaving as a proxy and now having topology hiding with stripping the headers and look like a back-to-back user agent. But again, take it with a bit of salt. It's not really a full back-to-back user agent. But however, you see no record route headers. You see a single via header when the message leaves Kamailio. The contact will be Kamailio, so it will look like Kamailio. It's originating the invite, but actually it's just removing headers, keeps them in Redis database, and put it back on the way to the caller. A distributed message queue, and so on. Again, a lot of features. I just put here the links if you want to read more, because I want to go to the storage backends and be in time for the happy hour a bit later. Of course, just to remind, we are at the Expo Hall in the booth. If you want to learn more about these new features and get clarification, we are more than happy to discuss, and we have more cookies there, so that's also a good reason to stop by during the breaks. So the storage backends, I think no one is kind of running a VoIP platform without having a choice of where I store the user profile and where I have to store maybe location information for whatever purposes like redundancy, high availability, and so on. And over the time, as an open source project, we got contribution from different companies, different people based on what they wanted to use. And this is the scope of the presentation from now on and the main topic for my presence here. So I categorize them in 3: SQL, NoSQL, and in-memory. And trying to look from the perspective which is more flexible, which is faster, which is more furious than the others. And this is actually specific for your use case. So sometimes, and many times actually, I combine them. And it's up to you to use it. Sometimes the benefit is the knowledge in-house. Sometimes the benefit is its interaction with some other application, and so on. So I'll go to the major one, because here I listed, and these are by category, but I'm not going to approach all of them, just the major I consider to be there. And then we can have like an open discussion if you have questions about others that I haven't approached, because there are quite many here. So MySQL and now MariaDB was actually the first backend that we added. It was even before releasing CP Router as an open source project back in 2002. We had in-house development at the Research Institute since autumn of 2001, and that was the first option. The same module is working now with MariaDB, although they are kind of slowly diverging, although they aim to keep the compatibility, but there are some differences that they don't really affect now that much, but in the future we might have to diverge as well. The community, it's large, you have a lot of documentation, MySQL, it's easy to use, but now the main concern starting a few years ago was MySQL was acquired by Oracle. Oracle is known to be project killer, or is always looking for licensing, and is more legal oriented rather than open source fan. Although they claim to be the biggest open source contribution because they bought Sun and MySQL and a lot of other. But they started to kill Java and some other projects that they control now, and people are somehow concerning about it. A bit of a mixed feeling here is this some proprietary extension which are actually useful from the user point of view. So they added this replace unsigned int. It's actually not an SQL standard data type, but people are using it. And then if you want to switch from one backend to another, you may get some negative impact on this one. So we are trying to keep an abstraction layer inside Kamailio that will make it work with MySQL, Postgres, or in the same fashion, but sometimes we need to add some mode params to control this one. Otherwise, actually, to make it clear, these backends are not really visible in the config file. They are used by authentication module to fetch the password, or by user log module to push to the database the location records and so on. So a part of loading a module, setting some parameters from there, it's not much interaction with the MySQL module itself in the routing blocks. Then Postgres probably was the second, and also quite popular, and even more and more popular these days, especially here in North America. I think Europe is still MySQL from my perspective as I perceive it, but from US and North America, it's more request for Postgres. Still open source. Used to be a bit heavier to use from the user experience point of view. They added replication a bit later, but now it's probably maybe even better than MySQL. I would have to say that. Alex Balashov, which is one of our guys here, it's a big fan of Postgres. It's very customizable also from the perspective of the indexes that you can build. So you can have like sort of a native longest prefix matching with the Postgres tables. So Alex can give you more details if you want to discuss about it. It's better if you want to deal with the documents like JSON and so on. They started earlier on this one, so they're kind of competing also, or going a bit into NoSQL market. So I don't have anything against on Postgres. I'm still using MySQL in most of my deployments, but if a customer wants Postgres, I'm more than fine with it. As now a lot of people are looking into, you know, small embedded devices, IoT, I wanted to highlight the SQLite. So MySQL, Postgres are server-oriented. They are huge application. If you need to deploy Kamailio on a Raspberry Pi to route between your LEDs in-house and so on, notification, that could be a good choice. It's also quite popular in our community. It's well-maintained and development. Of course, some people start with it and then they discover I need to scale, and then, okay, it's a bit how I connect two Kamailios to the same SQL. Then you need to migrate to MySQL Postgres, because the purpose of SQLite is not that one. But it's a good choice. And of course, if you need something else that we don't have, there is a UnixODBC connector. I listed in the first one. You can connect to any other database that we don't support. And actually, the beauty that we actually offer to you is this SQL Ops, which is like Swiss Army knife of the SQL operation in the config file. So it's up to you whether you use Postgres or MySQL, or even both of them in the same config file. It's fine. That's mainly for the modules inside the modules, the code. But then if you want to do SQL operation in the config file, you have to load this module, which is on top of the other. And now you have the full flexibility of using any kind of SQL query, SQL statement, insert, update, calling a store procedure or function from Kamailio routing blocks. And if you get a result, you get it accessible via variable. So here is like an example that you can take and use. So we have the subscriber table where we keep username, password. You can add another column. I call it status, where you keep like active, inactive for your users. And then in the scripting languages, I have the first if there with $F_U, just to do a sanity check if the from username has the characters I expect to be. And then I query this subscriber table, fetch the status. This is routing block scripting languages. I have this DBR, which gives me how many rows were in the result, and then I get the value with the index, the last if there, DBR. RA, it's just the container ID. It's up to you to choose a string there. And by index, row 0, column 0. If it's inactive, then practically I mark that user is somehow maybe hasn't paid the bill, and I just reject the call with SL send reply 403 inactive caller ID or so, and exit. Otherwise, if it's active, or you could put there whatever values, it's up to you to do different choices, like, okay, if it's a premium user, send it to a dedicated channel and so on. So it's up to you to extend it, and you have, again, the full flexibility of the SQL language in your routing logic. We also have, on top of these backends, a module that might not be that popular or well-known out there, but could be useful, especially for backup redundancy. It's called DB cluster, which tries to be like a pseudo-clustering layer. So practically, you can define a couple of connections and group them in a cluster, and then you say write to all of them at once, or try serial writing. If one is returning an error, try to write to another one. And the connection could be actually to different database systems. So could be a MySQL on like central MySQL, and for backup you have one locally, but could be a central MySQL and using DB text locally, which is text files. So you map the same two connections on a cluster ID, and then which one is available based on the algorithm you choose, parallel, round robin, or serial. So round robin could be when you have a lot of traffic and you have a pool of MySQL servers and you do a query one by one to each, so they don't get overloaded. So it could be, at least as I said, for backup redundancy purposes, something that you can use. Of course, MySQL, Postgres, they have their own clustering and solution, and you can go for it. The hybrid SQL backends are actually implementing our internal database API, but the underlying engine is not SQL. So this would be, we have at this moment for Redis, MongoDB, text that you can use. I haven't listed here because I'm not using it that much. We have also BerkeleyDB as a DB API implementation, and Berkeley is not an SQL engine itself. Redis was added this spring. As I said, we had quite some work on a couple of database connector aspects, and actually it's very performant. The guys at Zipwise, the one that I mentioned already, contributing the RTP engine, they contributed also this module, and they, prior to this, they were using the MySQL cluster, and when they added, they got way more performance with using Redis cluster. And then it's just you replace a mode param and then authentication location. Your configuration file is the same. It's only the database connector that changed in terms of mode param and so on. I put the link there for the presentation at Kamailio Award from Andreas Grenig, the developer of the DB Redis module. So I don't really want to focus, but you see there the benefits in terms of the performances, what you need to take care of, because again, it's not really an SQL behind it, but it's working fine with authentication, location, and the modules we have. The MongoDB, it's the one I developed, and practically it was a pressure more from the web world that they use JSON. MongoDB is more like a JSON-oriented storage engine. And then if you store, you have a web app that is pushing information in a JSON format and store it in a MongoDB, you can access it natively from Kamailio. Like user is changing the password, we'll push it in a JSON in Mongo, and now Kamailio fetch the password from the Mongo database. And DB text would be more like an alternative to SQLite. So it's not a server, it's using text file to store records or things like that. So this was developed from scratch, and actually it's one of the really old modules inside Kamailio. Before SQLite could be installed in small devices on like 2002, 2003, 4 time. And actually it's used by some deployments out there, including Kazoo default configuration. It's using DB text module. So again, these are just drop-in replacement for MySQL and Postgres. You don't interact much into config file, and you cannot use SQL Ops with this one because you can't send an SQL query to this. But we have NoSQL connectors, which are the equivalent of the SQL Ops, but this time it's specific for each of these modules. So we have the Redis connector, which is NDB Redis module, like no database, like we have the DB for the SQL or database API implementation, and then NDB would be like no database equivalent of that. And now you have full flexibility of doing any kind of Redis command from Kamailio config file. And here it's actually the example of how you can do active call limits with many Kamailios and storing information in a Redis database. So when you get an invite, will be that route invite. I use here a sort set, if you are familiar with Redis. So for each, it's per domain in this case. So it's like a carrier, and you don't want to send more calls to that termination provider because you have like a number of channels with them. So RD, it's the destination address host part or IP part of that. And we count how many we have associated with this. So the key is the domain, and then in the set you can put the IP addresses for this termination provider. If it's going over the AC limit, which is a variable here, but you can replace it with 10, or you load it from the database with SQL Ops per provider. So that's a variable, but you can change it with whatever you want, we reply no more channels available. Otherwise, we add this invite into the sorted set with zadd, and then we also store the call ID as just key value, and the destination, its domain is the value of this key. And we set also an auto expire just in case the by is not flying to, the key will be deleted automatically, and we don't, let's say, have hanging calls and limit the traffic there. And when you get the by, you just need to remove the key from the Redis. So practically, it doesn't matter where your call is coming in, if the destination is. So if you have a couple of Kamailios, you have a Redis cluster, you share this information very easily between them with Redis. The second one would be MongoDB. And here it's an example of fetching the password with MongoDB API, so not using the database API. We have the alternative for it, but for the sake of the example, and it was a question before, how I can do authentication with other kind of backends. So here is the example. I do a query, like find by the username, from username, and then I get the password in the JSON document, which is returned by the Mongo. I extract it with JSON. That's our module parsing JSON documents, and then I pass it to this PV auth check as a parameter. So the second parameter would be there, the value of the password field from the JSON document returned by this Mongo find one. We have many other functions, so practically you can execute different or whatever it's exposed by the MongoDB as an API. And the result, it's a JSON in the config file, and then you have actually two options. JSON and JSON modules are the ones that you could use and extract and build whatever JSON document you want. And the last one would be this in-memory storage, and these are actually brewed in-house, and actually we optimize it for Kamailio needs, so it's just furious. We didn't look at, being rather easy to use outside of Kamailio and so on. They are pretty flexible, but the design was tailored and from the beginning made for Kamailio usage. And Fred does a good advertising of this module always. So actually, I had more or less something related to his presentation with blocking by source IP, and quickly change it to blocking by user. When you have, for example, a scanning attack. So, with a source IP, you can block it by user agent or maybe too many requests per second from that IP. But with the user, it's a bit more sensitive because the attacker could use like 1 second pace to try different passwords. So now how the blocking is done is by counting how many failures of authentication were in a row, so without a successful authentication. So then you can combine this hash table with authentication module. You see authenticated failed, then increment a counter in the hash table. Once you get a limit, in this case 10, so 10 authentications failed in a row from the same user, then practically we ban that user for, in our case, I think I put it a variable that var x, but could be like 900 will be 15 minutes, it's seconds. And we put an auto expire for this key in the memory, so if the guy is stopping for 15 minutes, it's deleted and a new authentication can come. Of course, this is a simple example to fit in the slide, but you can combine it like blocking authentication from that user from that specific IP. Because you can build the key using $si, which is source IP, not only $AU, which is authentication username. So it's up to you to tailor it based on the needs. And of course, you can also build whitelist in this way, like, okay, the user had a good registration, like authentication was okay from that IP. From that moment, you don't really start counting because you know the real user is there. But sometimes that could be tricky, like I'm traveling, I'm logging in from the airport, now you open the entire airport to your network. So again, this security, it's more sensitive to discuss about in a single table. But hash table, it really helps you with all this kind, and it's a good tool for it. And you can define as many as you want. You can use one for banning IP addresses. You can use one for banning by user, and you define and use as you need in your configuration file. And the last one that I want to highlight here would be the memory tree module. This would be read-only from the perspective of using it inside Kamailio. It loads the data from the database. You can reload it at runtime if you do changes in the database. So it's still dynamic. You can put information there, but it's optimized for matching. So it's an in-memory tree, and it's very suitable for prefix routing, which is in VoIP and telephony one of the most used routing mechanism. And the example here, again, you can just use it. Of course, I have some dots there because you need to do authentication and so on before. But when you got to routing out, the idea here is to map to a prefix, a dispatcher, group ID, and then based on that route with round robin or priority based or list loaded by number of calls, whatever dispatcher can do. So we have this empty match. We give first the name of the tree, which was defined before with the mod param m3 name numRoute, so routing by number. The DB table, it's the name of the database table to be loaded at startup and reloaded later. Type would be the value associated with the prefix. And then practically we do empty match, num route. What we want to match in this case is R uppercase U, the $R uppercase U, which is the dial number. And then practically in the empty val variable, you get the key associated with. And as I mentioned, this is practically what I expect to be a destination ID for the dispatcher. If it is not, I'm going to route via dispatcher group ID. It's why I have this $AVP DST ID at some point in the config file. And then it's just DSelect domain, the usual dispatcher routing logic, and you send out. So again, this is highly optimized. This is no matter how many numbers you have, the matching of the routing rule, it's in the number of digits you have there. So you have millions of numbers, it's still matching. If the prefix is 6, it will match in 6 comparisons. So it's really, really fast on this aspect. The drawback is you can't really push information back to M3 from Kamailio config file. You have to put it in a database, and the reloading actually happens. Traffic goes to the old tree until the new tree is completely built in memory, and all the information is memory. We quickly swap the trees and free the information from the old tree. So we don't affect the performances, because otherwise locking to update key by key, node by node will slow the performances. So again, it's why I'm saying flexibility might not be the main key here. It's just be furious for what I need you to do in this case. And with this one, I want to thank you for the time you allocated for attending my talk. Probably we have 1-2 minutes for the questions. And again, we are today evening at the party here, the happy hour, and tomorrow in the expo area for your questions and so on.
So I have a question in the back.
Please correct me if I'm wrong. As far as I know, Redis lives in memory. Is that correct?
You have an option to make it persistent,
Oh, okay.
But the way people use it, it's mainly in memory, but you make a cluster and you are sure you don't have all the nodes down. So if you have 3 nodes and 1 is still up, you are fine. When you put the other 2 nodes up, they synchronize.
Okay, that was my last the subsequent question. If you restart the server, what would happen to the memory?
Yeah, you just need to make the cluster. So, but there is a option to make it persistent. But to what I have been using so far, people are using clusters and ensure 1 node is up all the time.
Other questions?
Yeah, about Redis, is it easy to cluster them? Is it possible to cluster them?
No, it's one of the easy. It's why people are using it. And actually, to give a bit more advertising to the Redis, one of the most demanded features when in the past was, with Kamailio, you can easily achieve high availability for SIP routing. Because if you restart Kamailio during the call or you shift the IP to another Kamailio, people on the call, they don't notice anything. But if you restart RTP proxy because the users are behind the net, then they get dark or no voice, actually, no audio, and then the call has to hang up. RTP engine, which is the new kind of RTP proxy in our project, has high availability capability of RTP streams by using Redis. So Redis is really fast on writing to it and querying it, and then practically having a second RTP engine that takes over the IP, fetches from the Redis all this information about active stream, what's the remote IP and port, what's my local IP and port for that session, and so on. It builds it quickly, and probably you notice maybe 1-2 seconds gap, which can happen just because you walk and you had just a bit of missing voice into the stream. So again, Redis got kind of really popular in our project. We have 2 modules, DB Redis. You can just replace MySQL with Redis by replacing DB MySQL with DB Redis and a token like DB URL, and you are set. Of course, you have to populate information in the user profile is not automatically migrated by Kamailio, but config file from Kamailio point of view, it's probably 3 lines of changing from MySQL to Redis. 4 modules like location and user lock. If you have SQL Ops, then it's a different story. You need to use NDB Redis, build different queries, and so on. But just authentication, location, and so on, switching from MySQL, Postgres to Redis, or even to MongoDB, it's quick. Another one?
Any other questions?
He has another.
Sorry, I do work with databases a lot. So do you have a comparison between MongoDB and Redis? Like, which one would you prefer?
So I only use Redis when the companies wanted to use Redis because they had, as I said, mainly because they're web developers, and keeping the user profile, updating them was done by a web application which was using MongoDB. Otherwise, I actually use Redis. So I don't have performance comparison, but yeah, that's my experience. So. And also, as far as I know, MongoDB replication is sort of best effort. It's not really ensuring propagation that fast as Redis. So you'll have to read more. I try to stay a bit away from this because every such engine has its own bits, and not really bits, but big stuff that you need to spend time. And then as a consultant, if you take over that job, they expect you have the same knowledge about Redis or MongoDB as I have for Kamailio. So I try to say, okay, I can integrate with, but if you do some advanced stuff, hire a proper database administrator if it's SQL, or a proper Redis consultant, and so on, because again, it's a critical part of your deployment, and a telephony engineer doesn't really have the proper experience there. Or I don't try to be that guy. Might be some people doing very well, all of them. Okay.
All right, I think we're out of time. Just a couple of quick housekeeping things. Let's give Daniel a round of applause. And then I don't want to keep you guys from happy hour. They've moved it because of the rain. It was originally scheduled to be outdoors. If you looked out the window, it's a little bit rainy out there. So they have moved it to the same place we had lunch, in the National Ballroom B. So join us for the next 2 hours for happy hour.
So Michael is not invited to the happy hour. I mean, the Michael Hurricane.